So we're back with the second way on how to calculate concentrations. The second way, if you remember, is parts per million, usually denoted by a ppm as the unit for that. Here's the analogy that I want to use to help you understand this concept of parts. So in my family, we like to have homemade syrup on our pancakes or waffles, and here's the recipe. It's really simple. It's just 2 parts sugar to 1 part water. Now, the recipe reads as just parts, so that people can select what unit they want to use or unit of measurement they want to use in order to make whatever amount of syrup that they want to make. So if you choose cups here, 2 cups of sugar, then you just have to use cups here, so 1 cup of water. And so the unit is consistent that way. If you want to make a lot more syrup, you could say 2 liters of sugar to 1 liter of water. And so that's the only stipulation for the recipe, is that it kind of allows for you to have some flexibility on how much syrup you want to make. So that's the same concept for parts per million. All it means is that if I have a solution that has a concentration of 2 parts per million for the solute that's in there, let's say salt in water, and the concentration is 2 parts per million, that just means that I have 2 parts sodium chloride or salt to 1,000,000 parts of water. So here along the top, you'll notice that this is always our solute, and along the bottom, this is always our solvent. But needless to say, if I have 2 parts in 1,000,000 parts, then my concentration is going to be 2 parts per million. That's what that means. We just don't say 2 parts in 1,000,000 parts. To just shorten it up, we just say 2 parts per million. Now, I can substitute the word parts in for whatever unit that I want to substitute, just so long as the unit is consistent. So if I wanted to say 2 milligrams of salt is dissolved in 1,000,000 milligrams of water, then that would mean, again, that I have 2 parts per million. 2 parts, in this case the parts is milligrams, in 1,000,000 parts, milligrams. Now I can do this with any unit. It could be milligrams here, as long as it's milligrams on the bottom. If I chose milliliters here, then I would have to have milliliters on the bottom. Or liters and liters, or grams and grams. Whatever unit you choose, it just has to be consistent. Now the trouble with this, though, is that when I'm doing my calculations, I just have to have it in how many parts per million parts. But oftentimes the amount of the solvent that we have is not exactly 1,000,000 of whatever it is. And so what we can do to simplify this process is we can express the ratio in parts per million by changing the units up. And so if you remember from conversion factors that we covered a while ago, we talked about how to convert milligrams into grams and into kilograms and so on using the metric system. And so if I express these milligrams here in kilograms, then I know that a milligram per kilogram then is a part per million, because I know that there are 1,000,000 milligrams in 1 kilogram. And so 2 milligrams over 1,000,000 milligrams can also read over 1 kilogram. And so now when I do this in my calculator, you can see if I express these in units of milligrams per kilogram, I can just go 2 divided by 1, and that gives me 2, which is equal to 2 parts per million. And so this unit here, milligram per kilogram, is expressed in units of parts per million. And I can do this for volumes as well. Volumes is just milliliters per kiloliter. And then if I have a particular situation where my solute is a mass, so units of grams or milligrams, and my solvent is a volume, like a liquid of some kind, like water, so that would be in units of like liters or kiloliters or milliliters, then I can have a ratio set up for that as well, because I know that 1 kilogram of water is equal to 1 liter of water. Then the third setup that I can have is milligrams per liter. And so each one of these 3 set up, now all I have to do is I just have to make sure that I put in I put in my solute here, which is milliliters of my solute over the kiloliters of my solvent, or the milligrams of my solute over the liters of my the milligrams of my solute over the liters of my solvent. And so solute goes on the top, the solvent goes on the bottom. If you express it in these units, then you just go top divide by bottom, numerator divide by denominator, and that will give you your number in parts per million. I'm going to do a couple of examples just to illustrate this for you, so I'll be right back. Hang tight. Okay, so here's our example for parts per million. We've got 250 milliliters of water, and in that water, they did a test, and they found that that water had 2.2 milligrams of oxygen dissolved in it. Now, the question's asking, what is the concentration of the oxygen in units of parts per million? So again, remember, over here I've listed out what are those 3 unit setups that we want in order to calculate parts per million quite easily. And it's really just a matter of looking at the 3 that you have and selecting which one is best for the information that's provided to you in the question. So you can see this one is units of masses over masses. This is units of volume over volumes. And this is a mass over volume. So this question, if you look, you can see that I've got my solvent is in units of volume and my solute is in units of masses. So this one over here, milligrams per liter, is the one that I want to use. So if I set this up so that my numbers are in those units, then I can just go milligrams divide by liters, hit enter in my calculator, and that will give me my answer in parts per million. So milligrams here on the top, liters on the bottom. Now you can see the numbers here that I'm given don't fully match. My units of oxygen is in milligrams, and that's my solute, so that's definitely going to go on the top, and that is in units of milligrams, so I can just write that in 2.2 milligrams, and that works out nicely. But for the water, it's given to me in units of milliliters, so I just got to convert that into liters. So I divide that by 1,000, and I get 0.250 liters for the volume of my water. So now that these units are expressed properly with the numbers that were given to me in the question, now I can just go 2.2 divided by 0.250 in my calculator, and you hit enter, and that punches out as 8.8 parts per million. And that's it. That's all you really have to do in order to do these calculations. Select the right unit ratio that you need given or based on the information that's given to you in the question. And then one final little twist that you might come across is sometimes the question might say, hey, you've done a sample test of water, and the oxygen in that water is at a concentration of 8.8 parts per million. So what would be the units, or what would be the mass of the oxygen in a sample of water that was 250 milliliters? So then you just have to do some algebra here. You could solve for x and solve for that question that way, just by rearranging things and solving for the unknown. So it's set up the same way, it's just sometimes they might have you do it a little bit backwards. They also might ask you if they gave you the concentration of the oxygen and they said you had 2.2 milligrams of oxygen, how much water would you need in order to get that concentration? Then, you would set it up like that, where that would be your x value, and then you'd solve for x there. That's the only ways that they can ask you questions about this. So that's it for parts per million. We'll be right back with the last one, amount concentration.